Alright, hey everyone. So welcome to our second part. We've got quadratic equations in this case, and we're talking about going through by graphing them. So here we've got quadratic equations with one real root. So what are the roots of the equation if we had negative x squared plus 8x minus 16 equals 0? And so we've been taking a look at this before in terms of table of values on how to start off. You could also graph this out using the graphing technology. But I would like for you to take a second, pause the video, try to come up with what the graph of this looks like to determine the roots. Alright, so we mentioned earlier that we could do minus b over 2a to get there. So minus b would be minus 8. 2a would be 2 times negative 1, which is like saying negative 8 divided by negative 2, which is 4. So that really opens up a table of values for me to start to plot out some points. If I started off at 4 and did 3, 2, 1, 0, and 5, 6, 7. Remembering that my middle part is kind of my vertex point of my graph. Okay, so just kind of a rough sketch just to see where we're going to end up here. So I guess the easiest one to take right away would just be to do 4 to find out what this is going to be. So if I had negative x squared, that would be like saying negative 4 squared plus 8 times 4 minus 16. So that's going to be negative 16 plus 32 minus 16. Looks like 32 is going to be my value here. So after that, I'm going to go and I'm going to try out 3, and I'm going to plug that in just to see what I get. So negative 3 squared plus 8 times 3 minus 16. That's negative 9 plus 24 minus 16. 24 minus 16. Oh, I see what I did wrong here in the first one. I was like trying to figure out something's off there. So it's not 32. It's negative 16 minus 16 is negative 32 plus 32. It actually gives me 0 there. There we go. That makes a lot more sense. So negative 9 minus 16 is negative 25 plus 24. That's negative 1 as an overall value. So I get negative 1 here and negative 1 there. Remember the symmetry that occurs here between numbers that are equal distance away from the axis of symmetry. Next I have 2, so if I plugged in negative 2 squared plus 8 times 2 minus 16, that's negative 4 plus 16 minus 16, they're going to cancel out, so negative 4 is what I get here. So negative 4 and negative 4. Now, I can kind of see from here where this is heading. If x is 1 in this case for my next one, it looks like I'm going to end up with, let's see here, negative 1 squared is negative 1. 1 plus 8 times 1 is 8 minus 16. So that's 7 minus 16, which looks like it's going to be negative 9. So it looks like I'm going to get negative 9 and negative 9. So basically, I've got 4, 0, okay, right here. And then I can see afterward that the graph starts to open down. So at 3, I'm at negative 1, okay, here and here. And then after that, I'm going down to negative 4 for 2, here and here. And then I can see kind of where this graph is winding up, right? So it's just a quick sketch just to kind of visualize, but do you see how in terms of the roots or x-intercepts here, I only have 1, right? I've only got 1 value that is crossing or touching the x-axis at that point. So in those types of scenarios, I only have 1 possible answer when I graph this out. All right, so in the next one, the manager of Jasmine's Fine Fashions is investigating the effect of raising or lowering dress prices that has on the daily revenue from dress sales. And so we've got the function r of x is equal to 100 plus 15x minus x squared. And it gives the store's revenue r in dollars from dress sales, where x is the price change in dollars. So what price changes will result in no revenue? So remember that r of x is the revenue. So basically it's saying, what value of x can I get so I have no revenue? So basically r of x here is 0. So 0 is equal to 100 plus 15x minus x squared. And then I'm back doing the same thing that we did from before. So if I were to go through and kind of isolate where my values are here, and kind of pick out where my minus b over 2a is, come up with my axis of symmetry, or we could use the function and plot out what those roots are. So pause the video, either use the graphing technology to graph it out, or try to create a table of values and see if you can calculate it. So pause the video, give it a try, and come back when you're ready. Alright, so what I would do here is I actually like to write mine out in terms of decreasing polynomial size. So basically what that means is I like my squared terms first, my linear terms second, and my constants third. Okay, just to make it look like standard form, ax squared plus bx plus c. And then from here, now I can take a look at graphing it out. And so in this case, using the table of values like I mentioned before, it works out quite well. And we could also use the graphing technology to do the same thing. So kind of graphing it out, what we should notice if you use the graphing calculators or if you use the table of values setup is that we have two different values here, or two different roots that we end up getting for answers. And now those two roots end up being at x is equal to 20 and x is equal to negative 5. So if I had to skip by 5s here, okay, 5, 10, 15, 20, and so that would be negative 5. I've got two separate roots where this thing is going to go. And so I'm going to end up with a value here, or graph, that's going to kind of look like this. Now, what do those two roots tell me? And again, using the graphing technology, you can kind of see those values a little bit. We would have to look a little bit closer in to find things like vertexes and y-intercepts and that kind of stuff, but it's not asking for that. It's just saying, hey, when r is 0, right, when I have no revenue, what value am I going to get where it touches these points? Like, where does it cross this section, right, when y is 0? So those two sections happen to come at negative 5, and they happen to come at 20. And so from there, it says what price changes will result in no revenue. So basically, a price change of negative $5, okay, or a price change of $20 will result in no revenue. So using this idea of understanding the x-intercepts really helped me kind of figure this out a little bit more too, to kind of see where everything is. So again, for this stuff, because it's a graphing section, I really encourage that you're using Desmos or using the graphing calculators to kind of figure out just kind of where to plot out the x-intercepts, because you can visually kind of see them from those from the pictures, from those graphs. Okay, so a quadratic function with no real roots. So in this case now, same thing as before, I'll get you to pause the video, give it a try, and then come back when you're ready to go through it. Alright, so let's start off and get this thing in the right form. So 2x squared plus x plus 2 equals 0. All I'm going to do is move the 2 over to the right side. Then after that, I'm going to go through my minus b over 2a step, and I'm going to find out where this axis of symmetry is that can help me make a table of values. So minus b over 2a be minus 1 over 2 times 2, which looks like it's going to be minus 1 over 4. Okay, so minus 1/4 is what I get from my axis of symmetry. Now, after that, I can then take the minus 1/4 and we can plug it back in. Okay, so minus 1/4, if I plug that back into the question, okay, so I know my axis of symmetry in this case, x is equal to minus 1/4. So let's take 2 times minus 1/4 squared plus negative 1/4 plus 2 equals 0. So that's 2 times 1/16, okay, squared, negative 1/4 squared, minus 1/4 plus 2 equals 0. The 2 and the 16 can reduce down to make an eighth. So an eighth minus 1/4 plus 2 equals 0. Now I need common denominators for this thing, so I'm going to make an eighth minus 2/8 plus 16 over 8. Right, 16 divided by 8 gives me 2. 2 over 8 reduces down to 1/4. And now I have common denominators. So 1 minus 2 is negative 1. Negative 1 plus 16 is 15. So 15 over 8 equals 0, which is basically just telling me in this case where my 0 function is for this. Okay, so that means that I have a vertex of negative 1/4, comma, 15 over 8, right? 1 7/8. So if I were to graph this out and kind of visualize what this is from even previous stuff that we talked about from before, I'm at negative 1/4 would be just off of my x-axis. Okay, and then I'm only going up as high as almost 2. So my vertex is really just somewhere in here. And then after that, when I look at A, I say, wait a minute, A is a positive number. That means that this whole thing's just going to open up this way. So visually, I can see from the graph that this thing has no roots. It's never going to cross the x-axis. So I can visually see what that looks like. All right, so let's take a look at the next one. So the curve of a suspension bridge cable attached between the tops of two towers can be modeled by the function. We've got h of d is equal to is equal to 0.0025 brackets d minus 100 squared minus 10, where h is the vertical distance from the top of the tower to the cable, and d is the horizontal distance from the left end of the bridge, both in meters. And then it says, what's the horizontal distance between the two towers? So it's giving me an equation to start with. Now the idea behind this is that it wants to know the horizontal distance right across here. Okay, what's that distance moving across the top of this? And we can see that this thing makes that parabolic shape. So really, the distance between this, if I knew this number and I knew this number, then I could just subtract them, and that would tell me what the distance is between the two towers. And it wants me to express that answer in the nearest tenth. So give it a second. See if you can figure out how to solve for it. Okay, involving the quadratic equation. And let's see what you come up with for an answer, and then come back and check when you're ready. All right, so in this case, if you were to plot out that graph or look online with a graphing technology software, then what you could start to pick out again are the x-intercepts or the roots. And so we can kind of mathematically check and see what this is, because we've gone through and we've solved questions like this before. We can also take a look with the graphing stuff to see what we have here for an answer. So if I were to go through and graph this out, then what I have here is I've got h of d is going to be 0 when this thing is touching the x-intercepts, right? So basically picture your graph kind of coming through here. It's not necessarily saying that's where the origin is. It's not actually, because it's at 100 and negative 10. But it kind of gives us an idea, just saying like this axis right across here. So when my y value is 0, that's really what I'm trying to look for here. So we have 0 equals 0.0025 d minus 100 squared minus 10. So we've done questions similar to this before to solve, so I'm going to move the 10 over to the other side. Is equal to 0.0025 d minus 100 squared. I'm going to divide by my a, so 10 divided by 0.0025. Okay, so divide by 0.0025 here, divide by 0.0025 here. this works out to give me 4,000 on this side is equal to the root of d minus 100. Then I'm going to take the square root of both sides, and I'm going to get a value here that's going to need to be rounded. It's plus or minus 63.245 is equal to d minus 100. Then I'm going to take the 100 and move it over, so 100 plus or minus 63.245 is going to tell me what d is. So that means that the distance here that I have to work with, the first root is going to be 100 minus 63.245, so it's going to be 36.755. And then the other root is going to be when it's added, and I'm going to get 163.245. So then if I wanted to know what the distance is between my 2 points, okay, so between here and here, all I would have to do is subtract them. So 163 minus 0.245 minus 36.755 equals out to be 126.5 meters for a total distance. Now, I kind of went and ran through this using an algebraic approach to solve for it. If you were to go online and look at the graphing software for this, basically what you would end up seeing from this is you would end up seeing this line kind of start here, and it would come down, and it would go up right around here somewhere. And you'd have a scale that you'd match up with it, but you'd be at the exact same point here where you'd take that one and this one, and you just subtract the 2 points, and those 2 points here are going to be those two values. So that kind of gives us a little bit of an idea on how to go through and how to solve these questions. I do have a few other problems, obviously, that we're going to go through in practice. And so if you have any questions, please let me know. And otherwise, good luck.